Good day, everyone, and welcome to today's webinar, 5G in the Factory, How 5G IoT at the Edge Can Elevate Your Manufacturing Business Strategy. Today's program is hosted by IOT Solutions World Congress and the Industrial Internet Consortium. My name is Bonnie Gordon, and I am the Program Director at the Industrial Internet Consortium. A very special thank you to our sponsor for today's webinar, Generalitat de Catalunya, the Government of Catalonia Ministry for Digital Policy and Public Administration. Before we begin, I want to draw your attention to the chat feature on your dashboard. Please feel free to introduce yourselves to your speakers and fellow attendees. We've also included links that you can use to connect with our speakers on LinkedIn and Twitter. There's a download button at the top of the dashboard where you can download a PDF copy of today's presentation slides. We will be dedicating time for your questions today at the end of the webinar. If you have questions for our panelists, please submit them by typing into the questions tab in your dashboard. This webinar will be available on demand at the conclusion of the session, and it will be emailed to you. And now it is my sincere pleasure to introduce today's speakers. Marco Contento is the Vice President of Technologies at Telit. He is joined by Dr. Jens Jacobson, the Development Manager at HMS Network. Hello and welcome to you both.
Hello, good day.
Hello, everybody.
Here we are. Thank you. Thank you for the introduction. I will start from, let's say, a nice statement from Gartner, saying that the installed IoT endpoint for manufacturing and natural resources industries are forecast to grow up to 1.9 billion units in 2028. Which is a huge quantity of devices, of course, and where Telit has an important role here, helping the customer to connect those devices. How do we help customers? Well, in terms of product offering, we essentially propose products in the cellular space, coming from the legacy technology from 2G up to 3G, 4G, and the last 5G, which is the key topic of discussion of today. And along with these devices, we can also offer platform IoT platform that essentially help the customer to do device management and also to manage the connectivity part. Along with that, we also offer design review services and also certification services to customers that are willing to develop their application using Telit modules, and therefore we somehow reduce the time to market for those customers. We also offer other, let's say, type of activities such as validation test and manufacturing process, all that can help customer to speed up and be ready in the market without encountering big issues. Now, looking at the next, any particular, when we come to the 5G, we are in front of a transition. Essentially, we are moving from a situation where the connectivity was somehow used to for personal, let's say, usage, to collect data, to read email, things like that. And when we come to the IoT space, the users of this technology have been essentially to retrieve data. But now with the coming 5G technology, we have the possibility to enable new use cases, in particular new vertical that so far were not possible to address with the legacy technology, so 2G, 3G, and also 4G. So in this regard, there's been a lot of effort in the industry, from regulatory approval activities, standardization, chipset vendor, device vendor, technology providers, and spectrum holders, in order to enable this new technology that is promising, and is promising actually to enable new use cases, as we said. So with a beneficial, of course, for the digital economy. IHS is estimating that the total, let's say, business that will stimulate in 2035 is in the range of 13 trillions. And the reason, because they are looking to 2035, is essentially because it will be more or less more than 10 years after the start of the 5G, or will be commercial. I mean, after 15 years of availability in terms of commercial, and in particular will be close to the peak penetration, because if you look at the history, in general, each technology has taken almost 20 years to reach the peak of the penetration. So essentially in 2038 or something like that, we will achieve the peak penetration of 5G. Said that, we of course, in front of us, we have a lot of challenges, because the 5G comes with a lot of technical complications. And in particular, when we look at the manufacturing segment, we expect that there will be the need to integrate new protocols. There will be also the need of new skills. And also, in particular, there will be most likely a change in the mindset, and in particular when we come to private network that we'll see later, what the way to operate will be something else, and will not be. So we'll move from a capex centric to an opex centric business model. Now, regarding the standard, and in particular, we all know that the 5G has been introduced with the release 15. And here we are essentially referring to the release 15 standard that was released in 2019 with the introduction of the two modes, the non-standalone and standalone mode, with the latest drop in June 2018. This year we have closed the release 16, and the next wave will be release 17, that will be essentially in 2022. What are the differences between these two or three pillars, actually? But the first one is what we call massive content, essentially to fulfill the needs of the broadband industry. So we refer to mobile handset, mobile computing, where we want essentially to extend the throughput capability, but not only that, but also the capacity of the systems, with the several new features that we see later on. The next is release 16, which is the most promising, and in particular for the purpose of the manufacturing in the industry, when we come to critical communication. So we talk about ultra reliable, low latency communication, and we look at the low latency application with latency that is expected to go below 1 millisecond. And the third wave would be to accommodate the need of the massive IoT devices. And so all these three essentially brings additional capabilities. And in particular, when we look to release 16, which is the most interesting for us for today's discussion, it will include improvement at the core level, but also on the physical layer, in particular to support low latency communications. That was initially implemented with the basic feature in release 15, but with release 16, there will be definitely a relevant improvement. There are other stuff like the support of LAN in 5G, plus, which is not related to our discussion today, improvement on vehicle-to-vehicle and vehicle-to-X communication. There will be integrations in terms of common API to access new services around 5G, and many other things. When we come to the transformation, in particular digital transformation, of course, several economic sectors will be impacted, that we can see here in this slide, from healthcare, manufacturing, energy and utilities, automotive, public safety, media and entertainment, and so on. But the fact is that essentially we will address all these different economic segments in different phases, and in particular due to the fact that each of the releases that we have just seen are able essentially to support specific capabilities. So with release 15, we mentioned before that we essentially address the possibility to extend the capacity of the system to bring more throughput to the end user, so better user experience, and therefore will enable some specific use cases, in particular broadband coverage indoor and outdoor. We talk about CPEs, indoor and outdoor CPEs, and largely because we think that this is essentially the key pillar. I mean, the key pillar for the 5G, and then we will essentially we see the evolution in the next phase. The next is Release 16 we mentioned before, that essentially will enable, in particular, the sectors like manufacturing, energy, utilities, and those segments essentially, plus also some other like the car industry and the logistic will also be relevant for that segment. The smart grid as well, in particular, when we come to the smart grids and when we need to do essentially synchronization on the network level in order to, let's say, improve the efficiency of the new systems. In terms of deployments or availability, I would say, of commercial 5G networks, situation is keeps changing day by day. This picture depicts the situation in September timeframe, but actually the number has improved even more. So currently there are more than 60 carriers worldwide in more than 30 countries that are already commercial with the 5G services. And there are more than 300 that have declared that they are investing in 5G and more than 120 countries. And these, of course, are related to commercial networks. We don't count here the private networks, which is also an important part of the 5G story, and we'll see later dedicated slides. So all these, of course, are targeting a different segment and with different also strategy in terms of frequency that they are going to or they are deploying. And in particular, when we look at the millimeter wave, which is one of the important, let's say, features or characteristic of 5G, we can comment here that generally speaking, the deployment are essentially in sub-6 spectrum, and in particular in Europe. And but when we look at North America, the carriers in North America, and when we look at Verizon and TNT, and we see later on few let's say slide talking about the situation over there, are essentially focused on the deployment of millimeter wave and along with, of course, LTE and sub-6. And here we refer to non-standalone deployments. Europe, as I said, is more focused on sub-6, even if there have been auction, in particular on millimeter wave spectrum, and there are also trials around in millimeter wave that will become commercial probably next year in different countries in Europe. In Asia Pacific, China is more focused on sub-6. Japan, we'll see, it will be both sub-6 and millimeter wave, and then Australia that is deploying sub-6 initially, and will enable millimeter wave in the next year, essentially, when they will be they will have allocated the bands. Here we are, Verizon, AT&T, and T-Mobile, are three leading carriers in US, where they launched already in essentially in 2019 the services in millimeter wave in several cities in North America. They are both also adding the support of sub-6 bands in order to provide essentially covered also for mobile handset, while millimeter wave is more oriented to cover, let's say, indoors environment like venues, shopping malls, and things like that. And not only that, by the way, because those are also important for private deployments. T-Mobile, that has nation coverage on band 71, 600 megahertz, but they are also considering to support or deploying millimeter wave as well, with more, let's say, focus on sub-6. So sub-6 will be essentially to provide coverage on metro area and also outside the cities, plus the millimeter wave support that we said is more important for let's say, closed environment in particular, and in order to reach more capacity and more throughput, and essentially to offload the legacy technology like LTE. All these deployments are done in non-standalone mode. So LTE is still an anchor in this context, and they plan to move to standalone next year or 2022, depending on the country. I'm sorry, or the carrier. Europe, as I said, is more focused on sub-6. Commercial launches has been already in 2019. We have a Vodafone that launched service in Italy, UK, and Germany. They use dynamic spectrum sharing in many countries at this point in order to have a smooth transition to 5G and reuse essentially the spectrum that they already have allocated for 4G. Deutsche Telekom, that is quite ahead. They are covering already 20 cities in Germany, and they are deploying in band 1 and band 78. Orange, that is also active in 5G. They have launched a service in Romania, Spain, and they plan also to cover Spain. Sorry. Telefonica that is present in Spain, UK, and also Germany. That they have already covered cities in UK, and they plan to extend the 5G coverage in Latin America. They've started service in SA, and they will extend also in SA mode. Asia Pacific, well, here we have to highlight the fact that China, and in particular with the 3 carrier, 2 of them, in particular China Unicom, China Telecom, have deployed 5G in standalone mode, so with a pure 5G core network. And China Mobile has started to deploy also non-standalone mode. They are focused on sub-6 bands for the time being, in particular in the spectrum 2.6 and 4.9, which is band 79. Japan, with the 3 carrier that have launched services on both sub-6 and millimeter wave, and they have anyhow prioritized sub-6 service. SKT, NKT, and LGU Plus in Korea, they have already launched a service in 2019, and there are already millions of subscribers in the field with subscription in 5G, and they focus their deployment in 3.5 GHz spectrum plus millimeter wave, where they put a lot of attention, in particular for the industrial applications. Telstra, Optus, and Vodafone Australia, they're also rolling out 5G in the major cities, and they're now testing 5G. There will be the auctions in 2021. And they will start to deploy millimeter wave as well. Important to notice Japan in particular, when we look at the private networks, Fujitsu was granted from the Japan government for the first private 5G network in millimeter wave in particular. I will see this topic later on in the coming slide when we speak about private deployment, which is a key topic when we look at the manufacturing. Now, when we look at the 5G in particular, let's see what are the new capabilities that 5G brings to the digital economy. We mentioned before millimeter wave. Let's say what it is. Essentially, because the operators are really hungry of spectrum in order to provide more capacity, more bandwidth, the ecosystem essentially has started to look into the new spectrum, in particular spectrum that is about 24 gigahertz, for the reason that there is much more bandwidth, and therefore there is potentially more capacity that we can introduce, and therefore we can provide more capacity to the public network and also more throughput. The cons of this, however, is the losses or the coverage that you can provide with the millimeter wave, in particular the fact that we cannot compare millimeter wave with the standard bands, in particular in the mid band or high band spectrum, or even low bands. And therefore, this kind of frequency can be used only in specific situations. We mentioned before, venues, shopping malls, and things like that when the distances are relatively low. And there is also an interesting use case, which is essentially in the fixed wireless access segment, in particular when we look at the customer premises equipment, where we want to, or we are willing to replace the last mile that can be either ADSL, VDSL, or fiber, and when there is no convenience to bring cables, so we can essentially leverage the cellular connectivity, in particular 5G and in particular millimeter wave, to provide internet access to the households. The next important feature that 5G brings to the digital transformation is what we call dynamic spectrum sharing, which is an important capability to accelerate the deployment of 5G without the need to refarm the 4G spectrum in particular, also 3G spectrum. So in a sense, this is the capability of the system to allocate dynamically the same band to either the legacy 4G technology or 5G, provide also a bridge as a transition from non-standalone to standalone deployment that sooner or later all the carrier will adopt. Our product, the FN80 family, will actually already support the DSS feature, which is a common request that we see across the carriers. The next is the service-based architecture, which is also an important key element here, and in particular when we look at the architecture of the network. This is essentially a new paradigm where the network elements are replaced by, let's say, software element, I would say, that are virtualized on an open hardware and allow the implementation of what's called network slicing. This is something completely new, and it is based on a mechanism where we have essentially, when we look at the different elements on the network, we have a consumer, we have a producer services. So the producer essentially has the capability to register on a repository function that we see here in the diagram to say, yes, I'm here, I can offer this kind of services. And the consumer element can essentially query and discover what are the services available, subscribe and get the authorization to use specific service, and then provide from that moment on a specific service to the entire architecture. Of course, this view is really simplified, but to give you an idea that from now on, there will be not any more different hardware element composing the full architecture, but there will be virtualized element, software element actually, and this will allow an important step, which is the network slicing, and in particular the possibility to support virtually separated piece of networks working on the same hardware that will allow the network operator to provide different or to serve different use cases and with different quality of services to the let's say to the users. And this is particularly relevant when we look at the private network implementation, in particular for manufacturing, because inside an enterprise there will be the possibility to serve different use cases, and we'll see later, with different quality of services, and therefore with a single network to serve different devices. The next is the concept of secure by design. Well, 5G, we have just mentioned that is based essentially on software implementation of the different network elements, and therefore the security aspect is an important element. We talk about software-defined networking, network function virtualization that allow flexible and programmable system essentially. So here essentially the security is something that has been considered since the beginning in order to provide the necessary feature and also flexibility to grow. I mean, and allow the organization to work with 5G in a secure way, maintaining all the feature, data integrity, privacy, confidentiality, and so on. In particular, when we come to use cases like we mentioned before, in the industry, we want to keep separated the piece of network and things like that. 5G will allow that. The next that is something that will come with release 17. In particular, we call it NR Lite, so new radio light. So far we have mentioned that there are essentially three key use cases. We mentioned broadband, mobile broadband in particular. We mentioned ultra reliable low latency communication that will come release 16. And we mentioned also massive MTC, so million of units of sensor in the field that require to be connected. Anyhow, there is somehow an area in the middle where we don't need the same throughput and like the MBB use case. We don't need the low latency capability like we will have in release 16. And we don't need to connect a million of devices. So we need something in the middle, something that will be somehow the replacement of the current or legacy technology like LTE, so something like LTE category 1, category 4. So NR Lite has the aim essentially to cover this gap, and this is something that we expect to see in terms of availability of chipset and also product certified in the market, not before end of 2022 or most likely mid of 2023. And in terms of capability, somehow will cover or replace the capability of the DLT mid-category chip, devices that we see today in the market. When we look at the deployment options, we mentioned before non-standalone versus standalone. What does it mean? When we look at the non-standalone, essentially we consider deployment where the core network is still a 4G core network. So essentially we leverage the investment that the carrier have already done today, adding the 5G RAN. So we essentially offer we combine the radio resources of 5G along with LTE. So in this case, the control plane and the user plane are delivered and provided by the LTE network, plus an additional user plane that is provided by the 5G radio access network. This will allow a smooth transition from the current implementation to the standalone implementation, which is also called option 2, where the core network essentially will be a pure 5G core network. We mentioned before that there are 2 carriers in China that have already deployed standalone, and this is actually the configuration. The truth is that those carriers, of course, cannot ignore the legacy users that are still based on legacy technology like LTE, and therefore they have to support essentially both what we see here, which is called option 1, which is the LTE, along with the option 2. Option 1 to serve the legacy customer, option 2 to serve the new customer that are compatible or compliant to the 5G release 15 in particular. When we look to private networks, the story will be a little bit different. And in particular, the tendency is to deploy the 5G core networks as option 2, so standalone. But there are also some mixed situations we see later in a specific and dedicated slide. When we talk about bands, of course, we have different characteristics, whether we look at the low bands below 1 gigahertz, or we look at the mid, high bands, ultra high bands, and then when we come to millimeter wave. In particular to the use cases, low bands are suitable for extended coverage, in particular when we look at the LPWA technologies such as LTE-M, narrowband IoT, but they are still used also for 5G, and in particular the example of T-Mobile we mentioned before. They have deployed nationwide band 71 for commercial users, of course, and not private networks here. And then we have the mid-high band spectrum, which is somehow capable to support high capacity, more bandwidth, and enable, of course, mobile broadband use cases. And this is also interesting for specific situation, I would say, but also mobile, private network deployment where mid-bands are considered in the C-band spectrum. We'll see later. And the last on top, of course, is the millimeter wave spectrum, where we can achieve even more throughput and capacity with even lower latency, in particular consider the higher sub-carrier spacing that millimeter wave spectrum can offer. But millimeter wave can also consider in indoor applications like in industrial IoT. We'll see later for specific use cases. Now, going back to for a second to the list 15, in particular, what are the early 5G use cases that we see around? And when we look at the smart factories, we see that the early adopters in this case are essentially customers that are willing to do trials and proof of concept and to test essentially the capability of 5G. As of now, of course, real-time use cases are not, let's say, addressable, and we will need to wait the next generation of chipset, release 16 compliant. They're also looking to use cases where they have to essentially guarantee the connectivity and privacy, and again, here, private networks is the reference. They want to leverage sub-6 spectrum, and we'll see later what are the deployments that we see worldwide, in particular for private 5G. And they want to leverage the service-based architecture, and in particular the network slicing approach. They are currently approaching a few use cases, but they have already envisioned several use cases that they will gradually approach. The tendency here is to essentially converge with a unique technology and provide a replacement for the legacy technologies such as Wi-Fi, for instance, or Ethernet. But of course, this will be a step-by-step approach. The next wave here is essentially related to release 16 and release 17 with the new use cases. And of course, here we address mission critical applications, and we look also at positioning improvement in particular in indoor environment. The intention here is also to leverage 5G to, let's say, to position the asset internally an enterprise for several reasons, because for instance, we need to configure a tool properly depending on the position inside the building. There will be the use of millimeter wave in some cases to complement the mid-band deployment, in particular when we look at the bandwidth and low latency, if combined, for instance, with multi-edge access computing. And there will be also the possibility to let's say combine, or let's say to have millimeter wave private deployment along with external and public deployment, for the fact that millimeter wave is easier to confine within the buildings. We mentioned before the private 5G deployment. That is quite an important part of the factories. And we have seen there are several ways to deploy private 5G. In this slide, essentially we depict the possible options. The first two are what we call 5G island. In a sense, the enterprise deploy its own hardware that can be either operated locally by the IT departments, or can be owned and licensed by the essentially operated by the network operator, an external network operator that provide, of course, a kind of service, consultant services to the enterprise. These two implementations, of course, can offer the better latency and also security and performance, I would say. But there are also other options that we refer to shared 5G network. And here we have different configuration of different architecture that can be also, let's say, deployed in different way. It depends essentially by where the cut is done, or where or what are the elements that are shared between the public network and the private network, and the type of interface that we consider. So we have a situation or configuration when essentially the G node B is shared and the remaining component of the network are essentially private. Second configuration can be, for instance, when the G node B is essentially shared along with the control plane of the 5G core network, and also the user database is also shared. And going ahead, there are even more components that are shared. And therefore, of course, each configuration can serve or can provide different performances. Here is a snapshot of the situation worldwide in terms of private deployment, and in particular, when we look at the infra vendor providers, we can count here around 100 of private deployment worldwide. And let's say that in terms of market segment, the leading segment here that we can see are the manufacturing and transportation segments, that the two together can offer almost, or represent almost 50% of the total deployments. So you can see that is really an important part when we talk about private deployments in the industry. Now, looking at the spectrum initiatives, we have several initiatives worldwide, either in Europe and North America. Belgium, that where in December 2019 they did a consultation to release or to use a band 77 from private deployment. France, they did something similar. Also, they have allocated spectrum in 2.6 gigahertz, as well band 78. Germany, which is a relevant country, where they have allocated 100 mega spectrum in band 78, and are also looking at millimeter wave spectrum for local application, either industrial fixed wire asset. Japan, they have allocated spectrum in sub-6, but also in millimeter wave. We mentioned before Fujitsu, they have deployed the first private 5G network in millimeter wave. Netherlands as well, but if you can notice, the majority of them have allocated spectrum in C-band, so around 3.5, can be either band 77 or band 78. And again, also the other countries like Norway, Slovenia, Sweden, and UK. Particularly important is the US, where there's a FCC has actioned the PAL license in North America in June this year, and they have allocated spectrum in band 48. The auction that can be up to 70 megahertz achieve a gross income that is around $4 billion. They have allocated almost 90, let's say more than 90% of the available license. Here, the spectrum has been, let's say, won either by private or enterprises, but also by the public network. This is to give you an overview of what is the situation in particular when you look at the private network deployment. It is, I mean, an important topic when we look at the enterprises and factories and so on. Okay, I will pass the stage to Jens for his part.
Thank you very much, Marco. So let me see here. So first of all, at HMS Networks, we have been connecting industrial devices for more than 30 years. We sell our products under 4 different brands. Anybus is connectivity between machines. XAT is connectivity inside the machines. E1 is machine connectivity to the cloud. Then we have Intersys, which is connected buildings. And finally, we have Web Factory, which is process control, analysis, and prediction. We sell our products to factories and other end users, but actually around 2/3 of our revenue is to machine builders and device manufacturers, which then in turn sell their products to the end users. Now, together with Telit and other partners, we have started our journey towards 5G for industrial production. So why do we actually need 5G in the factories? So to answer that question, I would like to start by going back 200 years. So 200 years, all production was craft production. So for example, if I needed a new shirt, I would go to my tailor, he would take my measurements and he would make a shirt specifically for me. And you can see that at that time, the volume per product was really low. And at the same time, you had a huge product variety. Then fast forward to around 100 years ago, we got what is called mass production. So now you were able to produce cars, for example, that were so cheap that ordinary people could afford them. But the cost of this was that every car was exactly the same. So we had a small product variety, but a huge volume per product. But actually, there was a market pull for more variety in the products because nobody wanted to drive a car that was exactly like the car of the neighbor. So that's when we went into this era of mass customization. So it means now you could order your car in different colors. You could have sunroof or no sunroof, memory seats on the driver's side or the passenger side, and so on. And now we are entering an era of personalized production. So this means that all the time we see the volume per product going down, and we see more and more volume, more and more product variety. So just to give you an example of what this means, I went into the Adidas website a couple of weeks ago, and I was ordering a couple of new running shoes. And then as I went to the checkout, they said, "Oh, do you want customization?" And yes, of course I wanted customization. So now I can put my name on the shoes. And it might seem like a simple thing, but actually when you think about it, this has huge implications to the factories, but also to the supply chain, because now you need to be able to produce a shoe specifically for me, but also quite importantly, you need to make sure that the shoes that are produced for me actually end up on my feet. So this is one example how we see that the volume per product is going down all the time, and we get this increasing product variety. And in order to obtain this product variety in a sustainable way, we are moving towards what is called Industry 4.0 or smart manufacturing, which has also a lot to do with digitalization of the factories. So it means that with Industry 4.0, we will be able to produce custom-made products, so products with a batch size of 1, but at the same time, everything will be automated, so we will not have an increase in the production cost. So of course, this is easy to imagine if we consider a greenfield situation where we build a totally new factory and maybe even a new business. But most of our customers already have their factories in place, and in many cases, you have the life cycle of the machines being up to 20 years. So when we talk to customers with existing factories, we see the stepwise approach where first you start out with current factory automation or Industry 3.0. And then the first step you see is that actually with many machines today, they're not connected at all. So you want to connect the machines, and then the first thing you want from the machines is basic KPIs. So how many units did I produce today? How much of the time was my machine under reconfiguration? And then when you get KPIs, you can start to optimize your production process. Then the next step could be traceability. So now you know the quality parameters of each produced product. Then you start to increase your automation by putting in the ADVs and the cobots. And then finally, you arrive at the full digitalization of your factory and Industry 4.0. So to give you one example, we see that if you go into a factory today, you will see that all the machines have been fully automated. And this is basically what we have done the last 30 years. And you will also find these amazing fully automated warehouses where everything is happening automatically. But in the same factories, you will also see that you have people carrying the material from the warehouse to the machine, and you have people carrying the finished products from the machines back to the warehouse. So of course, when we have the reducing volume per product and the increasing product variety, this manual handling of the material and the products becomes a challenge. So this is why we see that more and more AGVs and other mobile machines are entering the factories. We also see that we have some parts in the factory that are done using manual labor. So this is typically final assembly, product quality control, and so on. So this is also something that's hard to automate using existing factory automation technology. So here we see that the collaborative robots come in. So by using cameras and artificial intelligence, they are able to take over some of the tasks that are performed today by people in the final stages of production. So just to give you one example, if we look at a typical assembly line where we have a high volume production of one particular product, we can of course go in and put like automate this further and connect all the machines. But even if you do this, you will not achieve what we are looking for. So as an example, I'll put up the vision here from Audi. So you see in this vision of a future car factory, we have replaced the assembly line with something else. So we have machines that can move around freely within the factory. We have the products moving around by themselves or using AGVs. And we have the products also being supplied by AGVs. And of course, in this vision here, using flying drones. We also see that the people employed in the factory are not actually doing the production. They are part of the customer support cases where you discuss the design of your new product. And then probably most importantly, in order to maintain flexibility, there's no wires to be seen anywhere. So this kind of vision of the future, we need the strong and reliable wireless communication. But actually already today, we have a number of use cases already being used in the factories. So one example is wireless PLC connection, where you replace the wire between the PLC and the machine. We see a lot of machines that previously came with a HMI, like a screen on the machine, is now being replaced with a wireless connection, so you can operate the machine using a tablet. Then we see, of course, the autonomous guided vehicles and other mobile machines in the factory. They also rely on wireless connectivity. Quite often in the factory, you have rotating parts and things that move. So you can have connectivity to those parts using what is called drag chains or slip rings, but they're quite expensive. They are unreliable. So actually using wireless technology, you can have a more reliable connection at a lower cost. Then we have sensors going into the factories to monitor the process. We see more and more mobile machines. So in this example here, we have a CNC machine. Normally there's a person that puts in material into the machine. So this is something that can be replaced with one of the collaborative robots. Then we have cloud connectivity. So this is what we sell on our eWant brand. So basically it's connectivity of the machine to the cloud, that the machine builder who delivered the machine can log into the machine and do remote service. And then we have a lot of tools in the factories that was previously wired that are now moving to battery operation. But even if you go on battery, you still want to have connectivity to the tools. So for example, if you have a nut runner that you use to put in screws in the product, you want to report the torque for each individual screw to your quality assurance system. So when you walk into a factory today, you will see a lot of different technology in use. So you have wireless LAN for both voice and data. You have Bluetooth primarily for data. Then you have cellular for voice and data. You have DECT sometimes. And then for location and tracking, you see RFID, you see GPS for outdoors. Sometimes you have Bluetooth beacons. And then there's a lot of ultra wideband in use. And actually, all of this is working okay, but all the time we put more and more wireless devices into the factories, and also all the time the use of wireless technology becomes more and more mission critical. And this is why some of our customers are looking for one technology like 5G that can replace all the existing wireless technologies used in the factories with something that is more reliable. So at HMS, we organize our 5G activities within HMS Labs. So we analyze the technology, we build prototypes, and we take them to trade shows. So here we see examples from the SPS fair last year in Nuremberg. We have a small workshop in Birmingham in the UK. Then there's the Hanover fair last year in Germany. And finally, on the lower right corner, you see our CEO at the Mobile World Congress last year. So we do these kind of prototypes, and then also we do quite a few proof of concepts. And for the proof of concepts, we have a number of different devices that we use in the factories. So as Marco mentioned, you can use dynamic spectrum sharing. So quite often when you deploy the 5G networks, you get both 4G and 5G at the same time. So for some use cases, we can use 4G. So we have commercially available products for this. And then we have prototypes that we use for proof of concept that support both LTE and 5G. So that's what you see in the top right corner. So these are basically IP20 devices. So you put them inside the machine where they are protected from water and dust. Then we have what we call the cellular bridge. So this is a form factor that is waterproof, IP67. So this one you can put in the factory and you can clean it with a high pressure cleaner. And this is commercially available with with wireless LAN and Bluetooth. But for the 5G trials, we have a version of this device running with 5G. And then we have what we call the Anybus Bolt form factor. So this is also a waterproof device, but it's waterproof in the way that you put it on top of the machine. So you make a 50mm hole, you put in the wireless bolts, and then the outside of the bolt is waterproof, whereas the inside you have the connection to the machine. So we have this for LTE, narrowband IoT, Cat M1, and also as a prototype for Cat 4. So this is what we use for our proof of concepts. And if we look at use cases, they mainly fall in 3 different categories. We have the existing automation technology that is being migrated to 5G. So this is protocols like Profinet and Ethernet IP, where we basically do cable replacement. So instead of having a wired connection used in the factory, we use 5G to run these protocols typically between the PLC and a machine. Then we have all the mobile machines. So these are the AGVs primarily, but also AGVs with the robots on top. And these, of course, already today use wireless technology. But the challenge here is that as you put more and more mobile machines in the factory, it's becoming a challenge to get reliable connectivity to them. So here we are replacing typically Wi-Fi with 5G connectivity in order to achieve a higher reliability and better coverage. And then we have the third group of use cases, which is about digitalization of the existing factories. So here you have companies doing digitalization. They want all the existing machines connected to either some local cloud or public cloud. And then in addition to the connections to the machine, they are putting in a huge amount of sensors. And all of this needs to be done in a cost-efficient manner. So this is why they're looking for 5G technology to have the wireless connectivity from the machines and the sensors to the private cloud or the public cloud. So So the question is 5G the answer to Industry 4.0 and smart manufacturing? And actually, there's a lot of competing technologies out there, and at HMS, we are working with many of these technologies. But I believe that at least from a technical perspective, 5G is the technology that's best suited to meet the challenges of industrial production in the future. So thank you very much.
Hello. So thank you very much to both of you. And we did have several questions that came in, and we have about 4 minutes left. Unfortunately, we can't take any longer. So we will reply to everybody's questions separately via email. But I do have one question for each of you, if you could just give us your thoughts on this. So Jens, when do you expect 5G to be deployed in the factory?
Yeah, so actually this is a very, very good question. So on one side, we need the low latency that's coming in release 16, and we want the NR Lite that Marco described. But then on the other hand, we see already manufacturing companies getting licenses for private 5G. So for example, in Germany, there was an auction with 70, well, it's like handing out of the private licenses. So they handed out 78 private licenses in Germany. And when you look at the companies that got the licenses, many of these are major manufacturing companies. So they got the licenses, they are procuring the 5G equipment. You also see when you look at the priority access for CBRS in the US, here you see some of the major manufacturing companies getting priority access. So on one hand, this is happening already, and the use cases they start with is the one where you connect the machines to the IT systems, so you don't need the low reliability and the you don't need the low latency and the good quality of service mechanisms that we're getting in release 16. And then later on, you expand, besides the IT/OT connectivity, you expand with the more kind of hardcore manufacturing control technologies.
Excellent. Thank you. And one last question for Marco in the last 2 minutes. What is your biggest challenge to deploying 5G in your factory?
Well, as long as we want to use 5G for non-real-time communication, this is something that is already somehow viable today, considering there are also dozens of implementation around that have started to test it. Of course, when we come to low latency communication, reliable communication, and in particular, when we have the target or let's say the objective to replace cables in a different situation, of course, we need something else. We need a step ahead. We need to wait the release 16, as we mentioned before. So practically speaking, products that will come in 2 years from now. Surely now the technology is quite complex and also expensive, but I definitely think that going ahead, this technology will become more affordable.
Excellent. Thank you. So this concludes the webinar presentation for today. Thank you so much for joining us, and thanks again to Generalitat de Catalunya, the Government of Catalonia Ministry for Digital Policy and Public Administration. Please feel free to reach out to our speakers on LinkedIn and Twitter if you have additional questions. Thank you, and stay well, everyone, and enjoy the rest of your day. Bye-bye.
Thank you. Thank you.